Good morning, everybody. Miss Mocano here, and today I wanted to go over these dot diagrams in order to help you guys be better at identifying elements, compounds, and mixtures, okay? So you're going to see these diagrams, and in these diagrams, basically every different color represents the atom of a different element, okay? So we talked about this diagram right here in class where, which basically shows the classification of matter. It shows us how matter is classified into two different things, pure substances and mixtures. Pure substances can be further broken down into elements and compounds. For elements, as you can see in this diagram, it's showing us that we have only one type of atom in the element, okay? So that's why all the little dots are identical to each other, one type of atom. They are all identical to each other. They have the same color, the same size, the same everything, okay? One example of an element that we had in the previous slide is, for example, iron, right? Fe is the chemical symbol of iron. You can find that on your periodic table, which, as you guys know, looks like this, okay? And iron is right here on the periodic table, and all of the elements that we know of in the universe are also found on the periodic table, all right? So in an element, all of its atoms are identical to each other, and that's what an element looks like when we use these dot diagrams. A compound, we're getting to where you have two or more different type of atom bonded together. So the word bonded is important, okay? So two or more different types of atom. You can see in the diagram that it's showing that we have a red dot and these light blue dots, okay? Those represents different type of atom. So for example, the red dot could represent let's see, we have an example right here, NaCl, that's table salt. Na is sodium on your periodic table, and you can find it right here. And Cl is chlorine on your periodic table, a different element that you can find right here. Okay, so NaCl is an example of a compound. So if you were to show NaCl with a dot diagram like this, you would have to make Na, the sodium, one color, and the chlorine another color, okay? And you would have to show that they are bonded together. Bonded together, how do you show that in that diagram? You basically show your dots, right next to each other, like you see here, literally stuck together, okay? That's showing a chemical bond. So this is a compound. One other thing I want you guys to notice about a compound is that these molecules are all identical to each other. So I have this compound right here, that a molecule of this compound that contains one red atom and two blue atoms, and all the rest of the molecules in this compound are identical. They all have one red atom and two blue atoms. Okay, so they're all identical. Now going into mixtures, in mixtures, we have two or more elements and or compounds, and they are not bonded together. That is the big difference. So for example, you can see in this mixture right here that we have this molecule that we talked about before with the red atom and the two light blue atom, and then we have a completely different element here with the purple dot, and they're not bonded together. That's what makes the difference in a mixture, is that these things are different and they're not bonded together, okay? And then we talked about a homogeneous mixture, heterogeneous mixture, and the best representation of that is something like in a homogeneous mixture, such as apple juice. It all looks the same throughout. So apple juice, you can see how it all looks the same versus something like salad dressing, that you can see that it really doesn't all look the same throughout. You can see little flakes of different things in there, different colors, probably different consistencies, okay? And if we were to try to represent that in these dot diagrams, then a homogeneous mixture, you would show your elements, your atoms, and your molecules mixed together in a kind of uniform fashion, versus in a heterogeneous mixture, you can see how they're clearly separated, okay? Clearly separated right here. So let's go and look through a few more examples and kind of really try to get the skill down. So again, we have these definitions for elements are substances that contain only one type of atom. So I'm going to look here, which ones of these diagrams would be elements? Well, if I'm only looking for one type of atom, that means I'm looking for one color only, okay? One color, and it's all my dots should be identical to each other, okay? So obviously all of these diagrams right here have more than one color in them. They would not be representative of elements. But these two at the top have, this has only red, this has only blue, so these would represent elements, okay? Compounds, I'm looking for two or more different types of atoms, and they must be bonded together. So for compounds, all of these right here have two or more different kinds of atoms, because I see two colors in all of them. But then the next question is, are they bonded together? So here I can see that yes, they are bonded together, and my molecules all look identical. So all of my molecules here have one blue atom, two red atoms bonded together, and all my molecules in this look identical. So yes, this would be a compound right here. How about this right next to it? So I got a blue and a red bonded together. That makes a molecule. And then all of the molecules of this substance look the same. So this would definitely also be a compound. How about here? Well, here I have a blue and two red bonded together. So that's good. That's a molecule. But then I have a completely different molecule here with two blues bonded together. Okay, so that is a different, I got one compound and a different compound right here. So mixed together, that makes it a mixture. Okay? Similarly, right here, I got a molecule of a compound that's blue and red. And then I have another molecule of another compound that's blue and blue. I got a single element mixed in there. So I got a whole bunch of different things mixed together. That makes it a mixture. And in this one on the bottom, I have, let's see, I have two different kinds of elements. I have a blue element and a red element. They are not bonded together. So that makes it a mixture. Remember, the definition of mixture is two or more elements and or compounds that are not bonded together. And let's finally go to the last one and have a look at this. So for this one, how would we classify it? So I'm seeing here that I have an element of two different atoms of blue bonded together to form a compound, and then I got another compound right here of red bonded together. So I got two compounds mixed together. That makes it a mixture. And the second picture, I can see that all I see is red. All I see is these red dots. They're all identical to each other. That means all of the atoms are identical to each other, which makes it an element. In this third picture, I can see that I have a blue atom bonded together with a red atom, and all of these molecules are identical to each other. That makes it a compound. Let's see, over here, again, I have a white molecule, a white atom, bonded with a red atom, making it into a compound. All of the molecules are identical to each other, therefore this is a compound. Same kind of reasoning down here. I have red atoms and white atoms bonded together, forming a compound with identical molecules. How about this one? I have red atoms bonded together. That makes one type of compound. I got white atoms bonded together, making a different kind of compound. I got two different compounds in here. They're not bonded together. That makes this a mixture. And finally, in this last picture, I have a molecule of, I got a red atom bonded with two white atoms, making that a compound. And then completely separately and not bonded to it, I have a red atom of an element right here. And these are not bonded together. I got a compound and an element not bonded together, making this a mixture. Okay, so this is basically how you go about classifying elements, compounds, and mixtures based on these kind of diagrams. And again, the last step in this would be that if you see something like this from mixtures, if you see one which is more or less, it looks kind of homogeneous throughout, meaning that the atoms and the compounds in it are, the molecules in it are dispersed more or less evenly throughout the mixture, then that makes it a homogeneous mixture. If you see something where there's a clear separation, so all of these purple atoms are clearly separated from these molecules up here, then that would make it a heterogeneous mixture. All right, hope this has been helpful to you guys, and I will see you in class.